Thank you. Hi everyone. So I'm going to whistle through this. Thanks to Michael for kicking us off. So I'm going to talk to you today about a building that we completed some 2.5 years ago. The work that we've been doing in London has been very similar to the work that Michael's been doing in Vancouver, and we've been bouncing ideas off each other for the last couple of years. So that's definitely a very important factor in what we're looking at here. So this is particularly about cross-laminated timber. This is a building we finished in cross-laminated timber. Cross-laminated timber, very simply, is European spruce timber planks, which are glued and with using a PVA based adhesive at 90 degrees to each other, and then formed into large panels which come up to about 16 meters by 3 meters long. Those panels are then put through a computer router, and the windows, doors, etc. cut out. And I can feel that bird's going to die at any minute. I can hear like gunfire in the background. So this comes through the machine here, and so what the architect draws on the computer then comes out of the factory and arrives in England through the Channel Tunnel from Austria. So you can see this is a European spruce here, very, very straightforward. This is our site here. This is the East End of London. Nasty, horrible, rough place. And this was a pub here, which we demolished and put our building. So this is looking at the structure of that building. When you put a timber building together, it's all about a very cellular construction. So it's all about making sure that every wall, every floor, etc., slab is working. So it's what we call like a honeycomb structure. This allows us to rotate the plans through the building, which gives us lots of different uses through the floors, or lots of different plan types through the floors. Oh, there we go. I don't know what to do now. So there's a there's a person. And so there's our plan here. So we have, as I was saying before, a very cellular plan here. So we've got 2 staircases in this situation, 2 elevators. These are rooms going through. So the thicker walls here in the cross-laminated timber, and the external walls here. So what this allows us to do is to vary the plans, as you can see, from one floor to another, keeping a very tight cellular arrangement through the building. The advantages of working with a cross-laminated timber in addition to the environmental advantages, are also very much about the fact that the timber itself, as large panels which have a cross-lamination, so much like a jumbo plywood, because they have a cross-lamination through them, then those large panels are able to act as walls. When they act as walls, they're also not only acting as a sort of in a column effect, but they're also acting as beams across the structure. So this is what allows us to have this very tall buildings, very complex structures. The amount of creep, that's the amount of the shortening on the edge as you build up in this building. This is a calculation up to about 15 stories, and the edge creep is less than 0.6 millimeters due to load. So, and with the moisture, these timbers are kiln dried to about 8 to 10%. And in fact, when we were building this building, we actually had about 1 inch of water on one of the floor slabs at one point, which was swept off, and then the timbers dried back down to 8 to 10%. So overall, the shrinkage on the building after completion is 24 millimeters, which is just under 1 inch, over 30 meters. In terms of stability, because you're looking at a honeycomb structure, the stability works very well. So whereas with a concrete or a steel building, you're looking very much at the shear forces, with the P delta forces working on this building, with the honeycomb structure, that's actually working, coming through the slabs and straight down into the foundations. So a very effective structure in those terms. For acoustic protection, so this is a section through our building here. So we're looking at 146 millimeters of timber for the floor slabs and 128 millimeters of timber for the wall slabs here. Then we have a floating screed here, which is a 50 mil floating screed on top of a compressed insulation, which gives us our acoustic separation. On the outside of the building, we have an insulation here. That's in this situation, it's only 100 mil of insulation, which gives us about a 0.18 U value. So very effective insulation. And then on the outside of that, it's a simple rain screen cladding. So in terms of fire and fire protection, the way that we work in the UK is through compartmentation, which is actually isolating the flats from the staircases. And we're able to do this by charring and by using plasterboard. So I'm just going to go back one, actually. No, I'm not. Am I? Okay, so this is us on site here. So this is the stair and the lift course going up here, and then the floors going round. The timber arrived every week on a Tuesday morning, and on a Wednesday morning, and on a Thursday morning, and then on a Thursday evening, the 3 carpenters who built this building went home back to Austria for the weekend. So we built a story a week. So 4 people constructed a story a week. So the building of 9 stories was constructed in 27 days. And we had built our first CLT building about 5 years ago. And so we've been able to actually hone down the argument to discuss with our clients about what the advantages are of building in timber. One of those advantages, as you can see from this time-lapse photograph, has been the fact that we didn't need a tower crane on site. So you can see that we've just got a simple mobile crane. I think you're going to see it in a second on the site here. So this is London all around. You can see this is the middle of summer because it's grey. And so this is our mobile crane here. And when our Austrian carpenters had finished building the building, they stood on top of the building and they recited a poem in German, which is traditional. So this is halfway through the build process here. Lots of the advantages of building in this material actually came through the practice of actually doing it. So, for instance, we have this is our first fix for the electrics here, so these simple plastic tags. And we spoke to the electrician. The electrician explained to us that when you build in a concrete building, when you're an electrician and you first fix into concrete, that's how you start as an electrical apprentice. And you spend your first 18 months drilling into concrete. And then when your shoulder joint disintegrates, then you are taught about electricity. But working in a timber building, the atmosphere was fantastic. Everybody called me Andy and everybody was whistling, and there were birds even in that building. And so with this build, so this is our first fix here with the wires coming through and the pipes, etc. here. The building is then covered in gyprock. This is for surface spread of flame, and also for our very cautious client, who was very worried that the building wouldn't sell if people knew it was built out of timber. In fact, some nasty architects released it to the press as the building was going up that the building was built out of timber, and the building sold off plan in 1 hour and 15 minutes. So this is, again, very, very simple technology. It's a platform construction, so each floor is on the wall below, and each wall sits on the floor below. And where we have a balcony here, that's a torch-applied felt, and you can see very simple all the way through. The timber, the panels themselves are screwed together with angle brackets, 3-inch galvanized angle brackets with 4-inch screws. And that's what the finished product looks like. And that was our site waste after 9 weeks. And that's the finished product. And this is one more I'm going to sneak in before the bell goes. This is a project we're working on right now at the moment. It's under construction as we speak. This is Whitmore Road, and actually a lot more complicated in many ways than Murray Grove. Whitmore Road is a mixed-use building, which is not so cellular in its construction. So on the ground floor we have a yoga studio. This is actually concrete here because we're adjacent to a canal. On the first floor here we have a series of small studios. On the second floor here we have a photographic studio which has a 5-meter ceiling and a 9.5-meter span, and it's 25 meters long. So we're putting an open box right in the middle of the structure, and then on top of that we have 3 duplex apartments on top of that. So this is our site here. This is the canal. This is the section here, so this is the photographic studio, the residential above, the offices, and the yoga studio at the bottom there. And the elevation against the canal. So these are some of the models looking at, so we work very closely with KLH, who are a manufacturer of CLT, and with a couple of different engineering practices. And this is some of the software that we've been working with them to develop in terms of looking actually how the timber is working under different types of deflection, so under its self-weight, live load and dead load. And this is a model combining those 3 deflections on top of each other, which is an exaggerated model. But for architects, this is a very accessible way of building. So you have a very close relationship with your engineer again, which is a very rewarding process. So we can sit in a meeting and even I, with my limited engineering knowledge, can see that there might be a problem around here. So this is a horizontal displacement from wind load. here, also exaggerated as this model. So you can see that these here, the red arrows there, are actually the direction of the primary lamellas. So when you're building with a cross-laminated timber, the way that the top and the bottom panel go give your primary load path across the panel. So this is a slow animation of that, an exaggerated animation of those deflections. So you can see that as architects and engineers, because what we're drawing, because these is actually what we're building. So unlike with concrete or masonry or even steel buildings, where is that disconnect between what you're doing as an architect and engineer and actually what happens on site, here, because we're working directly on the machine with the computer, with the material that's actually going to be built, we're able to make very accurate path diagrams for that. So this is under construction. This is last week. So this is the concrete lower ground floor here against the canal. These are the panels being moved in here. So you can see in this we're also cantilevering as well. So we're cantilevering the edge here by 2 meters. And then that was a photograph that was sent to me yesterday. So this is us here. So this is the lower ground floor here with the offices, and this is the 5 meter high space here. I think I've got one on the inside. Oh, no. So this is the building running through here. So you can see the problems with this have been the fact that we are actually with this very large central space here is actually about been dealing with the shear forces across, because accentuating that by having this cantilever across there. And that's the book we wrote about it. And that's the end of my talk. Thank you very much.
Thank you very much for finishing before time. Thank you very much.